Hi guys, in TunaMetaPack version 1.4, several major changes have been made due to a complete overhaul of the existing pipeline for the body rig in Unreal 5.6. From now on, this tool will be divided into two modes, newest mode and legacy mode. The legacy mode follows the existing pipeline that has been shown in previous tutorials, whereas the newest mode introduces an entirely new approach. Because of this, the Metahuman for Maya plugin must be enabled when using the both modes. To begin with, as an example, I will generate new Metahuman LOD meshes based on this cartoon body. Now that all the LODs have been created, let's go ahead and build the body rig in newest mode. I'll quickly change the color display settings and delete all combined meshes except for combined LOD0. The newest mode and legacy mode each have different templates. Depending on the mode you select, you'll notice that the list of available templates changes accordingly. Since the legacy mode uses an older version of the template, I'll load the template in newest mode instead. At first glance, it looks very similar to the legacy template, but there's one major difference. This newest template closely mirrors the structure and data that are imported into the Maya scene using the Characator Assembler tool from Metahuman for Maya, particularly for body DNA. The only notable addition is the presence of up vector locators. Also, in this structure, there is only one root joint. This means there's no root driver joints in this scene. And here's another extremely important difference. From now on, the body also has DNA connected to it. In other words, just like the head rig, the body rig now requires a DNA file. If you check the Metahuman set template folder inside the Maya folder within your local user's documents directory, you'll see that folders are now organized by mode. Additionally, you'll notice that each template has its own separate DNA file. Now, let's set up the ref attach for our character. First, select the template mesh, then select the target character mesh you want to attach. After that, click the Selected Copy Ref and Attach Mesh button. Once this is done, just like I explained in the previous tutorial, a ref attach group will be created, and based on this structure, you can automatically place the joints. Let's go ahead and hide the template mesh for now. Open the View Ref Joint list and click the Body Joint to Ref Joint to Match button. This will automatically position the joints. But did you notice something strange? While the main joints were placed correctly, it seems that the correction joints weren't placed at all. The reason for this is that those correction joints are still connected to the DNA. If you open the script editor and check the warning logs, it tells you to open the DNA editor, go to the Geometry tab, and break connection there. In the newest mode of the Metahuman set tool, there's a feature that automatically detects the path of the body DNA file currently in the scene and opens the DNA editor for you, just like this. Since the DNA editor opens with the DNA path already loaded, you can immediately begin working with it. Go to the Geometry tab, select All under the LOD section, and specify a new output path for the DNA. I'll slightly change the original file name and set a new save path. Now, click Break Connection. You should now see that all correction joints are fully disconnected from the DNA. Next, click the Body Joint to Ref Joint to Match button again. You'll see that all correction joints are now correctly placed at the positions defined in the Ref Attach group. As explained in the previous tutorial, up vector locators play a crucial role in automatically aligning joint orientations. Each major body joint has its corresponding up vector locator, and it's extremely important to position these objects correctly. The joint size looks a bit large right now, so I'll reduce it briefly for clarity. The concept of automatic axis alignment using up vector locators is still applied in the newest mode. The All Joint Axis Align Settings button is responsible for this functionality. This feature realigns the orientation of all joints based on their respective up vector locators. Make sure to align the joint axes before saving the body as DNA. This step is essential. As mentioned in the previous tutorial, only the joints checked in the View Ref Joint list will be positioned based on their corresponding ref joints. So if there are joints you want to manually adjust and keep fixed, make sure to uncheck them in the View Ref Joint list. For example, in the case of the wrist, even if its position changes without considering its child joints, that's because only the wrist joint was unchecked. This means its position remains fixed. But since the child joints are still checked, clicking body joint to ref joint to match will update their positions according to the ref joints. The same logic applies to the ankle joints. If you uncheck both the left and right ankle joints and reposition them manually, then click body joint to ref joint to match, only the ankle joints will retain their adjusted positions, while the rest will update normally. While adjusting positions like this, you may notice that twist-related joints can sometimes appear misaligned. In such cases, you can use all joint axis align settings again to fix their orientation. However, since we've only updated the left side up vector so far, we now need to make the right side match the left. This is where the up vector mirror button becomes handy. It lets you easily mirror the up vector locators from one side to the other. Similarly, there's also a function to mirror all body joints. So, if your model is symmetrical, be sure to take advantage of that feature. I'm going to manually adjust the positions from the spine up to the head. First, uncheck all the related joints in the ViewRef joint list. When you start making adjustments, you might find it a bit inconvenient that moving one joint also moves all the connected joints. In such cases, you can press the D key while moving the joint. This allows you to reposition it more freely and precisely. Don't worry about the axis changing for now. We'll take care of that at the end by running all joint axis align settings. Once you press the All Joint Axis Align Settings button at the end, you'll see that all joint orientations are now correctly aligned. And if your character is symmetrical, it's best to run Mirror Up Vector and Mirror Joint before pressing the All Joint Axis Align Settings button. This ensures perfect left-right consistency. Also, if you want to save your Maya file midway through this process, make sure you first save the DNA through the DNA editor so that the joint connections are properly stored. After that, you can safely save the Maya file. Likewise, when you want to make further adjustments later, it's a good idea to reopen the DNA editor, run break connection, and then proceed with the edits. Alright, once all your joint axes are properly aligned, simply click Save Current init.jnt data in the DNA editor. A message box will appear asking if you want to save the geometry data as well. If you click Yes, and if your current scene contains meshes with the same names as those defined in the body DNA, the geometry information in the DNA will be updated to match the shapes of those meshes. Since I previously generated all the LOD meshes, and I still have meshes in the scene with matching names, I'll go ahead and save them as is. Of course, the DNA file itself will also be saved during this process. All of these meshes you see here, their data has now been written into the DNA. Now, if you try moving the joints, you'll notice that the DNA is correctly reconnected, and everything is functioning as expected. In short, this step in the Geometry tab is where you save the initial transform data of the joints into the DNA. Alright, now let's move on to editing the joint movement logic. First, open the DNA editor with the connected body DNA file. Go to the Behavior tab, and you'll see a list of expressions. But in the context of a body DNA, this list isn't particularly meaningful. These entries are simply RBF driver indicators, and they don't actually do anything. So it's completely normal if clicking on them has no effect. In the legacy mode, you likely used the Epic Pose Wrangler to modify poses. However, in the current scene, you'll notice that no pose-related solvers are present at all. That's because in the newest mode, the Pose Wrangler is no longer needed. Let's now enable this newly added checkbox labeled RBF. These entries inside might look very familiar, right? Exactly. These are the RBF solvers that were previously used in Pose Wrangler. And now they're built directly into the DNA. When you select a pose logic inside the DNA editor related to RBF, you'll see the pose reacting accordingly. Currently, since skinning hasn't been applied yet, let's switch to the Subtool tab and use the Auto Skin Load feature. Since we're only applying skin weights to the body LOD meshes, let's uncheck all the other unnecessary options. The skin will only be correctly loaded if the scene contains skinned meshes with names matching the prefix naming pattern shown here. Additionally, the body LOD meshes must have names that match those defined in the XML file. Oh, looks like the deformation is already pretty well adjusted. Now let's go ahead and edit the logic. I'll start by modifying the logic for the lower arm. First, make sure to set the DNA output path. When you click on a logic entry, you'll see a list of associated joints appear, confirming that the logic is correctly linked. Next, click Break Connection, and you're free to modify the joints however you like. Let's try adjusting just one joint slightly as a test. Yes, you can see that it has been successfully applied. Let's go ahead and modify a pose logic with a different angle as well. To maintain consistent movement behavior, it can be quite useful to key the joint transforms from the original logic, and then paste that key data onto another pose logic entry. Looks like we're getting close to the desired result. For cases like the bicep, rather than adjusting it manually, it's often much more convenient to use the Set Weight Logic feature. This feature allows you to select a logic item and then adjust the weight based on the joint currently selected in the scene. In this case, I'll reduce all movements of the bicep to half strength, 0.5. You might recognize this feature as being similar to the Scale Pose function from Legacy mode. And yes, that's correct. However, in newest mode, the Set Weight Logic function only supports one logic at a time, so you can't apply weight scaling to multiple poses simultaneously. So, although it's a bit more manual, you'll need to go through and adjust each logic entry individually. Let's now do the same for the triceps. But this time, I'll make it so that it doesn't move at all, using the weight logic feature. Actually, if you want the joint to have no movement at all, you can also use the Clear Selected Logic function here. However, if you want to retain just a bit of movement, then using weight logic is the better choice. Great. Now, what about the pose logics on the opposite side? That's where the mirror logic feature in the DNA editor comes in. The mirror solver function you used in the old Pose Wrangler is now handled by mirror logic in the newest mode. Unlike before, mirror logic now allows you to select and process multiple rig logics at once. Simply select all the logic items you want to mirror, and then click Mirror Logic. It will apply each mirrored version in sequence to the corresponding mirrored logic item. You'll see it, applied the first selected logic, then the second, then the third, fourth, fifth, sixth, seventh. Just like that, once you save it into the DNA, you'll have a clean, efficient way to mirror only the pose logics you want very easily. Let's now apply the same approach to the thigh and upper arm. This time, I'll try to handle everything using only the weight logic feature as much as possible. If you've previously worked with Pose Wrangler, this workflow should feel quite familiar and intuitive to you. And for those of you who are new to these tools, I recommend learning not only from this newest mode tutorial, but also from the older Pose Wrangler workflows. Having both perspectives will definitely give you a more complete understanding. And before running any mirror logic or solver, make absolutely sure that your character model is perfectly symmetrical. If it's a mirrored character, you should have already run mirror joint and mirror up vector in the previous steps. All right, now let's try loading the newly created body rig DNA from scratch. We'll be using the Character Assembler tool provided with Metahuman for Maya, but keep in mind, this tool requires a pre-existing Metahuman character to function. Now, we're going to copy the DNA file we created earlier, navigate to the folder where Ada exists, and replace the body DNA file with our own. For now, we're going to load only the body, not the head. Also, skip loading textures for this step. The Ada data can be found inside your Documents, TunaRig, Metahumans folder. Since it was installed automatically when you set up the tool, you can just use it as is. Everything has now been successfully loaded. You should be able to see that all the modifications we made earlier have been applied correctly. You can even open the DNA editor again at this point and continue making adjustments. No problem. All the LOD information was saved properly into the DNA as well. And that concludes our walkthrough of the newest pipeline using the Metahuman Set tool in DNA Editor. I hope this tutorial was helpful to all of you. In the next session, I'll show you how to merge the head and body within the newest pipeline. Thank you for watching and staying with me until the end.